What if an AI could see the invisible? And no, we're not talking about ghosts, but something way more costly. All the hidden energy leaks that are bleeding heat and money from our buildings. So today, we're going to dive into some brand new tech out of Sweden that does exactly that.
It's a frustrating question, isn't it? I mean, you pay your energy bills, but all these unseen cracks and failing insulation could be just silently draining your wallet. And the worst part is, they just get worse and worse over time, totally hidden from view. So the real question is, how do you fix a problem you can't even see?
And listen, this is a huge problem. We're talking about buildings being the single biggest energy user on the entire planet. And the main culprit? It's not the shiny new skyscrapers. Nope, it's the millions and millions of older buildings, the ones built way before we were all thinking about energy efficiency. They're just hiding all these costly, invisible flaws.
So, for a long time, the main tool for this job has been something called passive infrared thermography, or PIRT for short. Think of it like this. It's basically giving building inspectors heat vision goggles. A real superpower, right?
Okay, but here's the catch. That superpower? It comes with some serious downsides. Sure, PIR works, but you need a real expert to understand what they're seeing. The whole process is super slow, it's a ton of manual labor, and honestly, even the pros can get it wrong. And that can lead to some big mistakes, like missing a major problem altogether.
So you've got this powerful tool that's just really hard to use effectively. And that gap, that's the perfect place for AI to step in, which is exactly what a team of researchers at Umeå University in Sweden thought. They decided to tackle this problem head-on and see if they could automate and, just make the whole inspection process better. But what's so cool about this, and you gotta hear this, is how they train the AI. Instead of teaching it to spot every single type of leak or crack or defect, they did the complete opposite. They only showed it examples of what a perfect, super energy-efficient building looks like. It's kind of like training an apprentice by only having them study flawless masterpieces.
Yeah, there's a technical name for this. It's called one-class classification. And the idea is pretty simple, really. The AI just gets this incredibly deep understanding of what's normal. Once it knows exactly what a perfect building's heat signature is supposed to be, it can instantly spot anything that looks, well, weird. Anything that doesn't fit the pattern gets flagged as an anomaly.
So here's how the whole thing works, broken down into 4 pretty simple steps. First, you just snap a regular, everyday photo of a building. Step 2, the AI looks at that picture and predicts what the heat signature should be. Then it compares that prediction to the actual thermal photo taken of the building. And finally, step 4, any big differences, bam, they get flagged as a potential energy leak.
All right, let's walk through a real example so you can see exactly what I'm talking about. It all starts with something super simple. Just a standard color photograph. Yep, just like one you'd take with your phone. That's all the AI needs to get started.
Okay, so from just that one regular photo, the AI does something amazing. It generates a predicted thermal image. Now this is the real magic right here. What you're looking at isn't a real heat map. Nope, it's the AI's best guess. Its model of what a perfectly efficient building should look like based on all those normal examples it studied.
So, now it's time for a reality check. We bring in the actual thermal image of the building, the one captured with a real heat camera. This one shows us what's really going on with the heat, warts and all.
And here it is, the big reveal. The AI basically lays its perfect prediction over the real thermal image and looks for the differences. It's kind of like a game of spot the difference. And anywhere they don't match up, you see these bright spots? Those are the problem areas. Those are the unexpected heat signatures that point right to a hidden energy leak.
Okay, so this AI apprentice sounds pretty smart, right? But how does it actually stack up against a real, seasoned pro? To find out, the researchers ran a blind test. They put their algorithm head-to-head with a human expert who's been doing this for decades.
So, how did it do? Well, pretty darn good, actually. The study found a relatively good agreement between the AI and the expert. The AI flagged a lot of the same problem spots, which is great, but it wasn't perfect. The AI would sometimes get tripped up by things a human would just instantly ignore, like a warm car parked out front or someone just walking past the building.
So this really highlights that each one, the AI and the human, has its own unique strengths, right? The AI is all about speed and scale. It can work 24/7 and never gets tired. But the human expert, they bring context. They know that car is irrelevant. And as the expert in the study pointed out, they can go inside the building to investigate, which is something the AI just can't do.
So, look, maybe the AI isn't going to replace a human expert for a super detailed, one-off inspection. At least, not yet. But its real power, the real game changer here, isn't about replacement, it's about scale, incredible, massive scale.
I mean, just think about it. You could mount these camera pairs on cars or even on drones. You could then just drive or fly them through an entire neighborhood or an entire city and automate the whole thermal inspection process. You could create this huge, detailed map of energy waste, and you could do it super fast and way cheaper than before.
But with that kind of incredible power comes a whole new set of problems, right? I mean, if we start scanning entire cities like this, what about privacy? And thankfully, the researchers were smart enough to think about this ahead of time.
So they actually brought in legal experts to look at this. And what they found was that, yeah, collecting all this data presents, and I'm quoting here, a legal risk. The report even drew a direct line to all the privacy battles that companies like Google faced with Street View when it first rolled out.
So, to get ahead of these legal issues, especially with big privacy laws like GDPR in Europe, the assessment laid out some key recommendations. First, anonymize the data. Blur out anything that could identify someone. Second, be totally transparent with the public about what you're doing. You also need to give people a way to ask for their data to be deleted. And linking that data to a specific street address, well, that's going to require a whole separate, very complex legal study.
And all of this leaves us with a really big, powerful question. The technology to map out the energy waste of our cities, building by building, is basically here. We can do it. But the real question is, should we? That line between the public good and our personal privacy is something we're all going to have to figure out together as this kind of AI moves out of the lab and into our world.